9.1 number 13, they've given us this differential equation here, and the directions are a little bit odd. The first sentence here just says to verify that it's separable, but then I think they're kind of showing you how to go about doing that. So I'm going to kind of follow their playbook right here. The first thing I would do, regardless of what they said, is probably rewrite that y prime as a dy dx right there, and get, and make that here a plus e to the negative y, and set that equal to 0. And now what we would try to do is get all of our y's and dy on one side, all of our x's and dx on the other. And what I would probably do is begin by moving, let's take a look here. Maybe this term, I'm trying to see which way we do. This is definitely a tricky one right here. They want us to get it here as ey and then multiplied by dy. Okay, so what I think we would probably do is subtract that e to the negative y term to the other side right there and make that an x squared times a dy dx would equal, this would then be the opposite of e to the negative y. The tricky thing about this is that we want the y's on the left-hand side because of the dy in the numerator here. So we're going to do some odd stuff here, guys. We're going to multiply both sides by the same thing here. I need to get the dx out of where it is on the bottom of the left side, so that'll cancel that out, and of course I'll need a dx right there. That means I need to move this x squared out here as well. So I'm going to put an x squared on the bottom of both sides so that this x squared cancels with that x squared. And at the same time, boy, as weird as this seems, I'm going to multiply that x squared times the opposite of e to the negative y in the denominator on both sides. That will cancel with this. All right, so what does that leave us with? Boy, our left side now looks like a 1 over negative e to the negative y power and a dy. It's ugly, but that's what we have there. And on the right side, it looks like we ended up with a 1 over x squared and a dx after that. Now, I don't love the way this is written right now, but we did accomplish the main goal of separating our variables. All of our y's and the dy are on the left, all of the x's and the dx are on the right. And before I went to do anything else here at all, what I would probably do is recognize the fact that a negative exponent in the denominator of a fraction is just dumb. I'm going to move that whole thing up here to the numerator and change that negative exponent to a positive. So this is now going to become negative e to the positive y power multiplied by dy, and that's equal to a 1 over x squared dx. And the last thing they're kind of telling us to do for part A here is simply to divide both sides by negative 1 to make this a little bit easier to deal with. Oops, sorry guys, I should have done that. I don't know where this line came from, but let's get rid of that. Okay, so now our left side is going to be positive e to the positive y. That's a lot prettier than it was, and that'll just make this a negative 1 over x squared and a dx there. And that's really what they wanted us to accomplish here in part A. Write it as e to the y dy is equal to, okay, they wrote it as the opposite of x to the negative second power there times dx, but that's the same thing that we have. Okay, so that kind of takes care of part A. Now they want us moving on into what they're telling us to do in part B, but they're really just trying to guide us step by step here through what we would probably do anyway. Integrate both sides. So that's what you do after you've separated your variables. Integral of e to the y, same base to the same power divided by the derivative of that power, but that's just 1, so that was really easy. And yeah, now I see it. All right, writing this would have been easier here as negative x to the negative second power. Let's anti-differentiate that. We'll have an x. We'll raise this exponent by 1 to make it negative 1 and divide by that new exponent. Well, the negative 1 divided by that negative 1 is going to give you a positive 1 for your coefficient there. So a plus c at the end, and I think that's what they wanted us to do here. To obtain e to the y is equal to x to the negative 1 plus c. Okay, so that's what they wanted us to do in part B. Then in part C, what do they say next? Verify that y is equal to, okay, they basically want us to find the general solution. That means solve for y. So How do we undo an e to get y by itself? We take the natural log of both sides of the equation. And remember, guys, you cannot do natural log term by term. That's a no-no. You've got to do the natural log of the entire right side of the equation. So the natural log and the e cancel each other out, and we get y equals. And now what I have written there is actually what they were looking for. They didn't want us to simplify that at all, which is good because I'm really not sure that we can. A natural log of a sum, x to the negative 1 plus c power. So that's our general solution right there. That's all they wanted for part C. And then for part D, they want us to find a particular solution satisfying this statement over here, that y of 2 is equal to 4. So now we went from a general solution, which we had right here in part C, that basically says there's an infinite number of functions out there that have the original differential equation as their derivative because of the plus C. Now they're giving us the ammunition that we need here, guys, to find the one specific solution that does that. So, just to be consistent, I almost always go to green when I'm solving for C, and here we go. In for y, we're going to put this value right here, which is 4. That equals the natural log of, and we're putting this 2 in for x. 2 to the negative first power is going to be a 1/2 plus c. Yeah, and this is kind of why I usually like to solve for C before finding the general solution. I would have preferred to kind of do all this right up here, because now I kind of have to undo stuff that I just did. All right, if I want to solve for C here, which is my plan, I need to get rid of this natural log. And how do I do that? I exponentiate both sides, which is exactly what I was undoing right here. Anyway, fine. E to the fourth is e to the fourth. The e and the natural log cancel, and we get a 1/2 plus c. So let me scroll up here, guys, if I can. There we go. All right, so we're just about there now, guys. In fact, I'm going to save a now I'll subtract the 1/2 right here and get c is equal to e to the fourth minus 1/2, and there's nothing else you can do to clean that up. So there's our value for c. Now let me switch back to blue here and back to my general solution here. Here we go. We're now going to make this a specific solution. Y is equal to, it was the natural log of, in parentheses, we still have x to the negative 1 right there, or 1 over x, however you want to write that, plus your c value, which is now plus e to the fourth, and then a minus 1/2. And there's not really anything that I see there, guys, that we could do to clean that up. So I think that that is our specific solution here for number 13. So I think we've done everything that they asked us for there. So look at the scope of all of that in one big swoop here, guys. That's everything we needed to do for problem number 13.